from the equator, we see the stars directly overhead going straight. We see the stars off to the right in the distance deviating to the left. Would you agree with that? And the stars to the right, like deviating toward what you would call the northern hemisphere? Would you agree with that?
I'm glad you've actually mentioned stars, Brian, because we were supposed to be talking about stars, eclipses, and gas pressure. But yes, if you're stood on the equator, the stars passing directly overhead will be going straight overhead. If you look to the left, they'll be rotating one way. To the right, they'll be rotating the other way. You agree? You'll see the stars are not moving apart. It's not like gears in those time-lapse photographs, as you mentioned, often using wide-angle lens, so you can see a wide part of the sky. So there is
they're not deviating off to the right and the left. Okay, because just a minute ago I thought you said that they were.
So in this video is the various different claims that globers make about what happens at the equator, okay, and why we see the deviation, or if we even see it at all. A portion of them say we don't see it and wouldn't expect to see it. A portion of them say that we do see it because of wide-angle lenses, and then I have them arguing with each other. My argument is that we obviously see deviation in the time-lapse videos of the star trails at the equator. And upon first glance, it's good proof of a globe, but the devil's in the details, as usual. It's actually a globe killer, because if we can measure the separation and them moving away from each other, then that means they're going in different directions, literally, measurably. So in the background, I've had different videos playing with equatorial star trails and the moon in various locations, and it shows that according to its position in the ecliptic, it follows the stars according to where it's at. They would not even argue that. So it would follow necessarily that any heavenly body in the ecliptic would behave in the same manner, including the sun. So I'm going to use sun calc to prove the measurable separation using sticks and shadows. I will do this by substituting the stars with the sun, arcing over Cancer and ant-arcing over Capricorn.
So we definitely see the stars appear to converge and diverge at the equator, right? The star trails. That's not a question in anyone's mind anymore.
Do we?
No, I think they stay the same angular distance from one another the whole time.
So you're saying I'm talking about what we see. We see them appear to converge and diverge at the equator.
I don't know about that. Do we have evidence of them doing that?
Right at the equator, and I posted another star that's not at the equator, and it does appear that then later on in the night or whatever, at some other point, it does appear that they change distances. But this is only due to perspective, as you said earlier, Zanik.
Because of the wide-angle lens, yeah.
No, not because of wide-angle lens. Even if you took a snapshot of a single portion of the sky, it would only be closest at one point, and they would only be diverging from your position.
It's a wide-angle lens, and you can see that in the north, it's a wide-angle lens. You can see both the north and the south in this GIF.
It's like panoramic.
Right? Yeah, and you can see that when you're looking north, the stars are rotating one way. When you're looking south, they're rotating another way. What's the problem?
He's talking about the divergence.
This is the key question now, Zanik. Are you ready, sir?
All set.
We're at the equator now, right? And we look up and we see what you say, a straight line and a circle on one side and a circle on the other side, one going clockwise, one counterclockwise, correct?
Well, I know you see that with wide-angle lenses.
So here's Google showing and stating the stars curve away toward the horizon on either side of the equator. And remember earlier how I demonstrated the moon and the sun follow the star trails in the ecliptic. Well, I'm going to go to sun calc. That stick at the bottom of the sun, that's a time lapse of the sun, and that stick represents the shadow angles. So this is how we measure. So the stars over Capricorn, you see making a frown, there's over the equator, straight. Okay, then I just move barely above the equator, and you'll see the smiley face. So arcing in the Arctic, Antarctic in the Antarctic, smiling and frowning. So that's measurable separation. We can use sticks and shadows to demonstrate measurable separation. Now this is not predicted by the globe model. This is another example of how they try to use something for globe proof, and under further scrutiny, it questions their model altogether. Okay, you can't have perspective with stars gajillions of miles away. That goes against their model, their celestial navigation. It's just another example of how their proof kills their model. So the next time they try to use sticks and shadows to prove a globe, show them this video and point out that the stars are physically separating from each other.